Welcome to the IMechE webinar series. The nice thing about introducing a webinar online is I don't have to remind you about fire drills and turning your mobile phone off. My name is John Bickerton. I am past chair of the automobile division of IMechE. I'm a chartered member of the Institution of Mechanical Engineers, and we're really pleased to be presenting this panel today with a selection of luminaries from across the automobile industry. It's a really strong panel we've put together, and I'm really proud. In a minute, I'll introduce our host, Steve Cropley, who has, I believe, Steve, is your 20th anniversary with Autocar this year. So congratulations for that. I'll come back at the end and remind you to look at the IMechE calendar for other similar events, but I think this is going to be a really interesting debate. So without further ado, I'll hand across to Steve Cropley.
Thank you very much, John. Welcome everybody to this webinar, which is aiming to focus on the challenges and priorities of the British motor industry post-Brexit and post-COVID. Now that is a hell of a mouthful, as I'm sure you're aware. It's a big job in 1 hour. But we've got the people for the job. Let me introduce them. First of all, we have Mike Hawes, who's the CEO of the Society of Motor Manufacturers and Traders, which is the motor industry group, the club, I guess. His job is, he spent years advising governments, setting things into context for the likes of us, and generally knowing, having his finger on the pulse, and he's here to tell us stuff now. We have Richard Parry Jones, who is a very well-known engineer. As a young engineer, he sold excellence to the car industry, to Ford, which was his company. It worked. The bosses at Ford promoted him up through the ranks. He went to the very top. He changed all cars by changing Fords, which is a hell of a thing to do, and they've remained changed, I must say. So he'll have a lot to say. We're not quite sure whether we're going to be joined by Stephen Norman, who until recently was the managing director of Vauxhall, but he has lately done such a good job in the process of moving to Germany as sales and manufacturing vice president for Opel and Vauxhall. So he's also a luminary. We have Paul Markwick, who's a distinguished engineer, worked his way up through Land Rover, chief of various projects, to be CEO of the Vehicle Certification Authority, and then the Manufacturing Technology Center, and now he runs his own consultancy. So these people know everything. There's a hell of a lot to know about, mind you, of course. The thing I should say that although the air in the post-COVID firmament is full of talk of 2030, when internal combustion and petrol and diesel cars can't be sold anymore, and sales will cease. The thing I really want to know is how important it is for now to keep selling, keep manufacturing the cars we know. Mike, you'll have a view on that, I think.
Yeah, absolutely. And good afternoon, everyone. You're right, Steve. We're sort of coming out. Well, one hopes, as an economy, as a society, coming out of a pretty awful past 12 months or something, and that's had a major effect on the industry. We saw last year in terms of manufacturing, output was down nigh on 30%. Registrations down almost exactly the same. But at the same time, we have a government increasingly focused on the future, 2030, as you say, for the end of sale, what happens and beyond that. The challenge for the industry is obviously to make a shift in technology, the like of which no one has seen unless you're about 100 years old. It is that sort of scale of transition that is now required, and it is required in 10 to 15 years maximum. UK is going ahead of a lot of other established manufacturing nations, and we can debate whether that's the right or the wrong thing to do, but the challenge is there. But in making that challenge, we need to sustain the industry, because you want that transition to be a made in the UK one, and secondly, in making that change, we have to sustain the industry and the market in doing so. Whenever you just set a date many years hence without a plan, there is obviously, when you try and profile what's going to happen, trying to avoid that classic hockey stick. So you're bumbling along, and then it's supposed to rocket towards the end when you hit to 2030. We need to see a sustained, continuous, incremental change, which allows UK industry to prosper, but also satisfies the consumer and the consumer expectation. But I just can't underestimate just how difficult it's going to be to get from where we are to where we need to go. And it's going to take all parts, all players, not just the industry, to manage that transition.
Yeah. Richard, do you have a view of how this very thing, the hockey stick, is going to be handled in car companies? I mean, how can you get people in 2025 to buy the cars that you need them to buy? Because they're going to need to be encouraged to buy conventional cars up until a fairly late date, aren't they? Oh, not hearing you. I think you're muted, Richard.
I am.
Yeah.
I don't know if the industry has all the levers. It has some, you're right. But actually, I think what we see going on is shifts in government regulation and incentivization, shift in consumer attitudes as well, attitudes towards the environment, attitudes towards city air quality. And I think during this next few years, we see the sort of transition from the natural choice being ICE engine to the natural choice becoming an EV. So what I see going on is different manufacturers having different approaches. Some will basically delay electrification until the last minute and maximize the mining of the assets they have. Others, however, are deciding, actually, if this is going to happen, we'd rather be an early participant and stake our claim in this new market and gain advantage that way. So actually, I don't think we'll be uniform at all. I think consumers will have plenty of choice, and that choice will be fueled by different OEMs taking different approaches. Two common things. One, charging infrastructure. Without that in place, people's efforts to shift more and more EVs will be frustrated. The government has a role to play here, but I believe not to buy all, pay for all the charging points. Rather, make sure that private capital is incentivized and rewarded, and risks is mitigated for their investments. Because I'm sure long-term charging infrastructure will make money for investors. Right. But of course, right now, people are chicken and egg. How fast do I go? And that's where government can help bridge the de-risking of the initial investments.
Do you have any way of any notion of naming names about who might pile straight into the electrification and who might hold back?
I can only share with you what's in the public domain, obviously, but the obvious candidate here is VW Group, who, having been, through the nightmare of Dieselgate, they've obviously made a very clear decision to completely switch over as fast as possible, from what I can see, to on an electrified future. Yeah. So that's an obvious candidate. In terms of people who will hang on the longest, it's not clear to me what will happen in the UK that way. I think we need a global conversation as well, because 2030 is currently only a UK deadline. Europe will obviously not be far behind or copy, something similar will happen, I'm sure. But elsewhere in the world, very different approaches being taken. So I don't see ICE engines disappearing in 2030 at all. I think they'll, certainly in the UK, they'll be diminished as a primary model enormously. Hybrids will carry on, but ones that really work, not ones that are cycle beaters.
Yes.
And I personally think in other parts of the world, there will be still a market for ICE engines for even longer than 2035. No, don't forget, we have 500 million internal combustion engines not in cars.
Yeah.
In off-highway appliances and more machines and so forth, where again needs to be a revolution will take time.
I was hearing recently that in any case, the major expansion towards whatever it is, 100 million cars a year in the next few years is going to, or in the next sort of 5 to 10 is going to take place in India, Africa, and they're definitely going to go for internal combustion, aren't they, for the time being?
Yes, I mean, I think things will change, rapidly as these countries align with the global consensus on CO2 reduction, and also, I believe, very importantly, city air quality. If you look at the drive for EVs in UK and Europe, I would say, although the underpinning technology goal was CO2 reduction, the impetus, the catalyst for regulation has probably been, as much as anything else, city air quality, where the EV is seen as a dependable way of reducing emissions from internal combustion engines in city environments where air quality is increasingly a health concern.
Right, I see.
And I think, Steve, if I can jump in here, there's Richard making some very good points. I think you're absolutely right in terms of what happens globally. The 2030-2035 is the UK's statement. They're trying to ensure that there was sort of a global coalition towards that shift. We're hosting COP26 in November in Glasgow. You don't underestimate just how important that event is for government. This is post-Brexit, hopefully post-COVID, UK on a world stage. Now, for them to get all those other countries, all those other markets to sign up to some sort of pledge, and there will be sector agreements as well as national agreements, they've got to have a credible, they've got to, first of all, you've got to get your own house in order. So they have the target, but the credibility depends on also having a plan which allows you to deliver onto that target. Otherwise, how do you convince developing countries to accelerate their transition when they're sort of saying we want the economic growth? So I think, the UK government, we're seeing what the discussions that are taking place in Brussels at the moment. The industry is charged with a 37.5% reduction in CO2 by 2030. It's going to get tougher. Probably 50 to 60% will be what they'll settle on, and they only agreed 37.5% last year. So this is moving really quickly.
Yeah.
And you see the different. That's one of the major motivations behind some of the big OEMs. Volkswagen's obviously one of them. And it's going to be interesting that we always talk about, as a market develops, disruptors coming along. And there's a wealth of startups, EV companies being created. But if you read the Financial Times, other papers are available. They follow some of these EV companies, which to a certain extent they're characterizing them as a bit of a bubble. And the best stat from today's paper is, in terms of looking at established players versus these startups, it says that BMW's R&D budget is twice the cumulative amount of all those EV startups are going to be spending this year.
Wow.
Where do you put your money on? Is it these potentially massively overinflated market caps of some of these startups, or the traditional players, given their deep pockets in R&D and how quickly they will move to meet that consumer demand?
Very interesting, isn't it? I just quote you from something that was in Autocar. I would do this, wouldn't I? But just a few weeks ago, we called it the most radical, draconian, and expensive change in history, in automotive history. And yet I keep on hearing from engineers that this is an exciting time. So could the engineers among us tell us why they're excited? Paul, you might start off with that one.
I was hoping you'd come to me. Actually, Steve, I think it really is the most wonderful time to be an engineer right now, an automotive engineer. What inevitably makes change is a burning platform. And we have that around us right now with a number of things. The drive towards a low or zero carbon environment. We have the changes brought on by working practices during COVID. We have Brexit, and while we've got a deal, we don't know what that means yet to us. So for a young engineer or engineer starting out in their industry, I think this is a marvelous opportunity, because none of us know what the answers are yet. And there's going to be plenty of answers. I think both Mike and Richard have hit on some of the key issues right now. Charging infrastructure is the biggest impediment currently to rolling out large numbers of EVs, added to the high cost of making electric vehicles. And right now the government is offering up something like £3,000 a car for a pure EV, and then 350 quid to put a charging post at your home, which is, thank you government, but how sustainable is that? Traditionally, motorists through their fossil fuel taxes contribute about 50 billion to the exchequer on every time they fill up at a gas tank. That's going to disappear. So it's not sustainable to offer grants up while you've got less revenues coming in. There's a solution. There's an economic solution required there. Now, clearly, costs will come down as volumes increase. We all know that in the automotive industry. And clearly, we recognise that the best products win out, and Mike's numbers are great in terms of investment. Now, how good are BMW at turning that huge investment pot into great products? Well, we know they do. They do it regularly. But the thing that small startups have is focus. You know, they don't have big decision-making processes. They can crack on and do things. So I just think this is a marvelous time to be an engineer, and being a member of the IMechE. You know, I'm not just saying that. This is a real burning platform. I wouldn't say this is the demise of the internal combustion engine, because I wouldn't rule out alternative liquid fuels. Now, on the questions that are coming up, people are asking, what about hydrogen? And I think that's something we need to discuss. But it isn't an easy product to get into an infrastructure and supply locally. So hydrogen might work for, shall we say, an urban environment, a bus company or a delivery company that's delivering in an urban environment, and vehicles go back to a head office. But I don't see a huge hydrogen infrastructure replacing fossil fuels. I do see lots of work going on in fuels to bring low carbon fuels in. I think there is a continuum of our wonderful IC engines with zero carbon fuels. Anyway, I've probably said enough for now. Steve, come back to me when you get bored.
Richard, just give us a burst. I'm sure I can rely on you for an enthusiastic comment or two on the engineering challenges ahead.
Yeah, absolutely. I agree that it's a fantastic time to be an engineer, but then I can't remember when it wasn't. It's certainly the challenges, the scale of challenges, the relatively immature technologies we're trying to deploy at scale. And at scale means it has to be affordable, reliable, as well as delivering all the functional outcomes. And we're at the beginning of the learning curve, really.
Yeah.
So right now, you know, the scope for innovation, for fresh thinking, for fresh ideas, not only in chemistry, but actually in electrical architecture, in mechanical engineering is also very considerable. As an example, right now we have redundancy in the battery system. We have cells, we have modules, we have packs, and we have a vehicle structure into which they go. You almost could say there's 4 layers between the cell chemistry and the outside world. Now, I think we got here because it was a logical evolution pattern. But now people are looking at these 4 layers and saying, why have we got 4 layers? Why don't we integrate or combine some of those roles to reduce at least 1 layer between the cell chemistry and the outside world? So this is not only a game for chemists, electrical engineers. It's still, again, very much for mechanical engineers to figure out how to eliminate redundant structure and material.
Doesn't the pressure that's placed on manufacturers to get EVs into the market, at least in our market, doesn't that sort of militate against a bit innovation, because you've just got to take what you get and what you have and electrify it?
That was I made my point, really. I think when it comes to the cell, it's very hard for a smaller car company to design their own cell or to invest in chemistry that's unique to them. It's not practical. So most companies will go to the commoditized cell market. But a third of the cost of a battery system in a vehicle isn't the cell. It's the module, the pack, and the installation, including cooling and electrical connections and so forth. So that's an area where it's really ripe for innovation, for fresh ideas, which are low risk, really, compared with the chemistry, radical chemistry.
Yeah.
Chemistry changes are happening, of course they are, but they tend to happen in a parallel path rather than on the critical path of the individual car.
Oh, I see. That's interesting.
Steve, there's some interesting questions coming up from the audience. We touched on hydrogen, and perhaps if you can get the other panelists to talk about hydrogen. We're also talking about some of the more societal shifts, like how do you get charging stations into high density housing, or those things. So there's some very interesting questions coming up at the moment.
Yeah. But the thing is, I'd just like to move a little further into EVs for a minute, because I've heard Mike recently deliver on the challenge. Given that the government has decided that EVs are the solution for the time being, hydrogen or not, we have to the Brexit conclusions have rather made it necessary for us to build gigafactories at high speed. And Mike, you had some amazing statistics. Could you run through those?
You're right in terms of two major announcements that affect the industry last year from government. One was obviously 2030, 2035, which, whilst ostensibly government will say they were technology neutral, given that timescale, I think you're right, manufacturers are looking at what is the available technology that's commercial and can get you there. Now, that's obviously electrification. So we have to transition from internal combustion engines. And if you think about how significant that transition is for the UK, I mean, usually we make about 1.5 million cars, 300,000 or whatever, it's less than that vans, 100,000 vans, and 2.5 million engines. So that engine industry, that part of the UK manufacturing complex has to transition quickly. On top of that, we've got Brexit. Now, the Brexit deal, the TCA, was about 1,300 pages. How would I characterize it? Obviously, it was a relief to the industry to get a deal. If you think about what was said in 2016 to where we've ended up, the political ambition narrowed, and it was never about the economics, it was never about the industrial impact, it was about sovereignty. The result of the deal of where we are is, in actual fact, there was some movement at the end where the UK government did actually move and negotiate to support the industry. One of those areas is exactly that, around electrification, whereby what the Europeans were proposing was would have effectively meant that electrified vehicles will almost immediately be subject to tariffs when their internal combustion engine equivalents would not. Counterintuitive, but it's about industrial policy and environmental policy on the European side. Situation we are now is that you can benefit from zero tariff for electrified vehicles, depending on how much content is local. It's quite a generous allowance at the moment. That gets tougher in 2024 and gets even tougher in 2027. Effectively, that means as you get through this decade, you have to have batteries that are made in either the UK or Europe to qualify for free trade, given the importance and the cost of batteries as its proportion of the total overall cost of the vehicle. So, for the industry now, we have to be making we have to make electric vehicles to achieve increasingly international requirements, and to make them here, they're going to have batteries made either here or in Europe. So that means you say, okay, well, what are we making at the moment? We've got about 2 gigawatts. That's the factory outside the Nissan, adjacent to the Nissan factory in Sunderland. British Volt have committed to Blythe, just down the road from them. So that will give us about 15 gigawatts by 2024. We need 4 or 5 times that by the end of the decade to sustain the volumes that we currently enjoy, and we need those volumes to have the scale. So put that together, what it means is, you've either got a window to attract massive battery investment, or you're going to have to be importing it from Europe, because that's still our largest market. And if you're doing that, then it throws into question, well, if you're importing your batteries to a UK production, surely it's more efficient and more cost competitive to simply build closer to where those batteries are being made. So the industry now has, 4 or 5 years to work with government, and government, is on the hook for this. And, we've had discussions with secretaries of state. They say, one of their priorities is to attract this inward investment, and it can't come soon enough.
Presumably, the big problem is that the battery is so heavy that moving it across continents is a pretty stupid thing to do.
They're heavy, they're costly, and they're not that easy to move, because of the chemistry within them and so forth. It's not a cheap exit. Yeah, and at the moment, most of the European industry is doing that because they're sourcing from China, Japan, Korea, and so forth. But the European Commission's policy is to localize, basically force manufacturers to localize that production in Europe. We need to make sure we don't get left behind.
Yeah. Is there enough? Sorry, Richard, were you about to say something?
I don't want to interrupt your flow, but I wanted to kind of take a slightly broader view of why we're dealing with electricity as a primary solution set rather than other alternatives.
Okay, sounds good.
Okay, I'll go. So I think it's important to remember where the energy is coming from. At the moment, we use mostly fossil fuels in the form of oil to refine and produce fuel for either aircraft, aerospace kerosene, or diesel vehicles or petrol vehicles. It is a proportion of biofuel blended into those fuels, but it's quite small. Therefore, to tackle the CO2 issue, we need to fundamentally shift away from the raw material of energy into something renewable and zero carbon. That means really it has to be renewable solar or wind or tidal or wave, but potentially some nuclear as a sort of load leveler for protection when the conditions are not reliable for wind generation. In that case, we have electricity available in quantity, and that changeover needs to take place irrespective of what we do. We can make all the cars EV. It won't help if we're still burning fossil fuel as coal or oil or gas to create electricity. So we need the base generation capacity to change over, as we all know. That has to take place over the next 10 years to make sense of the government policy. So it has to be synchronized with two investments, have to be arm in arm, together with the charging infrastructure. Then people say, okay, why aren't we using hydrogen or thin fuels? My answer is, fundamentally, well, raw material is now electricity. It's not liquid, it's not gas, it's electrons with a voltage drop. And what we need to do is work out what's the best way of transporting that and condensing it to reuse it in mobility applications. And the answer at the moment and for the foreseeable future is it's going to be electric motors. powered by a battery. Now, it's possible that a battery won't be fit for purpose due to its weight and energy density for certain applications, for HEVs, for buses, for aircraft, certainly larger aircraft. And this is where I believe hydrogen and syn fuels can come into play, because they're not as efficient. Fundamentally, they're more inefficient than as total energy use from source to usage point as using electricity. And of course, electricity also has the advantage that most of the infrastructure is in place or can be adapted. But you may need hydrogen for special applications where you use the electricity to split water or steam into oxygen and hydrogen to create a much more energy dense fuel you can then use in special applications. Quite expensive, less efficient, but necessary compared with carry on burning kerosene or having these feasibly heavy large batteries. So on land-based transport, I can see this being possible for HEV, certainly, but most other applications, I think it will be either a range extender or not necessary. And I want to come on to the solution I believe we need to invest in is rapid charging. People are worried about how do they charge the vehicle? The answer, and the industry is investing heavily in this, is to create batteries in vehicles and charging systems that allow customers to charge up in 10 minutes or less. That means really it's no more inconvenient than stopping today for coffee, go to the bathroom, pay for your fuel in refueling. Average dwell time on a forecourt today is 11 minutes. So it's not that different because, of course, when you're plugged into the rapid charger, you can do other things because you need to supervise it, unlike filling liquid fuel. So I believe that we mustn't forget why we're doing all this. It's not like we have options. We have no option to meet zero carbon. We have to exit using fossil fuel for mobility.
I see.
Steve, if I can jump back in here. I mean, Richard raises a very, very good point. And he mentioned earlier about, industry have certain levers, but we don't have all the levers. We've set this goal. It can't underestimate just how important it is that the automotive industry and the infrastructure energy work together on this. Because what Richard has just described, you move to that model whereby you're substituting refueling for recharging by going to recharging stations. Now, we've got to get the consumer to make this transition. And the immediate thought, what drives consumers is obviously convenience. And it'll be most convenient to charge at home. I mean, we charge our phones every night, whether they need it or not. And there are certain advantages in that in terms of reassurance, consumer assurance, and also the potential to feed back into the grid to level off supply. But if the model is as Richard describes, which is entirely plausible, with fast charging, where you go to a destination or a charge point to charge during the day, such that you don't need to do that, that raises a couple of issues about how the consumer is going to react, and also how the industry is going to respond. Is it going to produce vehicles which are capable, allow that fast, rapid charging? Or is it, in terms of, especially during the transitional phase, you produce vehicles which are more, urban focused, more slower charging, trickle charging, because you don't need that large range. And the user, and in terms of cost, the smaller the battery pack, the cheaper the vehicle is going to be. So the industry's probably got to, could go in two different directions. If I can give two examples, let's use UK examples. That's what we're trying to promote here. Well, in terms of brands, anyway. Jaguar, I-Pace, large battery pack, large range, and so forth, fast charging, versus, so we say, something like the Mini EV, which is a much smaller battery pack. Massive difference in cost. You need the charging infrastructure to have that flexibility to do both. Otherwise, the charging strategy may dictate the product strategy. for vehicle manufacturing.
I see.
That's why the coordination, the cooperation is critical here.
Yeah, gosh. And is there evidence that of this happening?
Funnily enough, we've got a meeting this afternoon. We're trying to bring it together, and Richard is a former chair of the Automotive Council. No, we're trying to do it through that auspice. He's trying to bring in the energy sector and other elements of both the automotive and players, because this is not in the gift of any one sector, and coordination, I think, will be critical.
Is there enough knowledge yet of how batteries behave when their useful life is largely gone, and how they can be utilized? I know there are lots of theories about sheds in fields and all that, but saving solar energy, that spare solar energy and spare wind energy. But how realistic is this stuff? Does it look like it's working? And the other thing is, battery disposal is a question that's come up several times in our attendee questions here. Battery disposal is a gigantic problem, isn't it?
Can I chip in, Steve?
Yeah, go for it.
So there's a school of thought that says there's enough raw material now in the UK to fund all of our battery EV requirements. It's a question of recycling it appropriately. Okay, so if you read the press frequently, you'll get lots of people saying that we're destroying the habitat and the environment of so many faraway places, China, Africa. We're digging up lithium and other pretty nasty sources. But there's a school of thought that says there's sufficient now. We just need to utilise it and recycle it. So again, sort of echoing points that Mike and Richard have raised, we need to be a bit smarter about range and stuff like that. Okay, so we know, if you look at the stats, we know the average journey is 20 odd miles, and that's really no problem at all for an EV. So if you do a round trip of 40, a bit of spare capacity, you might say a 60 to 70 mile range is pretty good for most requirements. Now, for those of us who like to go long distances and not have to stop anywhere, then that's a different requirement. And Mike says the iPace has a huge battery pack. It's got a range of, 200 odd miles. Some of the bigger Teslas have really big ranges, but you're carrying around a load of redundancy. And one of the things that interests me, and I think we should talk a little bit about it, is usage change. So when we got into first lockdown on COVID, none of us went anywhere. Our cars sat on our drives, and I at the time wondered whether that was going to be a catalyst for changing how people view vehicle purchase. So our generation's used to buying a vehicle and having it on the drive. And even in good days, our utilisation is tiny, a couple of 3 hours a day at most. When you never use your car and it sits out there on the drive and all you've got to do is wash it, why? And so, you get into car sharing schemes. And if you're in a car sharing scheme, you can be a bit more choosy. You don't need to buy the one vehicle which compromises everything you need. So if I want to drive down to the south coast from here, right in the middle of the country, and I want to get home without stopping, that's a pretty long range. So why don't I borrow or rent one of those when I need it? Because most of the time at the moment, I'm only doing a round trip of 10, 12 miles. And I carry a lot of redundancy around with me most of the time. I think attitudes are going to have to change. And if you look at some of the questions coming up on the question panel, some people are rightly questioning this. Now, that's not necessarily good news for the auto industry if our pattern changes and fewer of us buy vehicles and we get into transport as a service rather than the more conventional process. Yeah, you've then got we've all bought a lot more online than we did a year ago, and that arrives in the back of quite a big van. And really, does it need to? So you get into much smaller. You can get into much smaller, last 5 kilometre delivery vehicles with very small energy requirements. A little more than bicycles and rituals, that sort of stuff. Yeah. So again, coming back to my initial thing, there's going to be a lot of change. We've got a burning platform. We have to look at things unconventionally. There is probably enough raw material for us to keep making the right batteries for the right time. Pick up on your point, Steve. I think new housing requirement designs are going to include a local battery pack. And at the moment, the plan is to fill that with used vehicle battery packs. Okay, so there might be 80% used. We've still got quite a lot of capacity for storing up overnight when energy is a lot cheaper to produce because less.
Presumably they come to an end as well, and they need to be disposed of in the end, or is that? Are you saying
they get recycled? Is my point, Steve. You know, we don't know how to do it yet, but we will do. We will be into recycling these things.
Yeah, I always remember being told by Richard, for another reason, that you just had to trust the engineers downstream. You know, that something would happen.
We are pretty good at solving burning platforms, right?
Yeah.
And you really need a burning platform to instigate rapid change, and we have that at the moment.
When we were doing something similar on this autocar recently, the question came up, and it's echoed here by the attendees about the grid coping,
yeah.
And but the answer we got from the grid was that this is what we do, we'll be fine. You know, they talked about smart charging and use
of change. You know, the massive grid we have now with the huge infrastructure and the huge costs of that will become more localized. So, you know, you're seeing a lot more sort of wind stations and other stations, solar stations. You can't drive up the motorway without seeing those as solar stations. It will become more localized. But I think government plan, I mean, Mike is probably a little bit closer to this. We'll discuss that. Government plan is for small nuclear power plants, not the massive, you know, huge giga things that we have planned at the moment.
Yeah,
but there'll be more localized nuclear plants to top up between, and again, Richard touched on this, to top up when there's no wind or there's too much wind or there's no sun or what have you. So we will change. Right.
Richard, I keep asking this question of lots of different people and getting different answers. The most recent quote I got was that the cost of batteries was plummeting. What's happening to the cost of batteries? Some people say, yes, but there's the disposal issues. Yes, there's the transportation issues. What is the trajectory of battery cost?
It is indeed plummeting. It's coming down very rapidly with scale, but also innovation. And I mentioned earlier the importance of the battery system, not only the cell. So all these things are happening as you have been told by some people. I've seen lots of data that confirms that, and there's more to come. We're not flattening it out yet. Conversely, as I mentioned the other day, the cost of ICE engines, unfortunately, is increasing.
Right.
The more severe tailpipe emissions requirements, mainly, are the cause. To meet the very, very severe tailpipe emissions, the cost of the chemical plant we attach to the engine to deal with the combustion is getting higher and higher. So this is making the crossover point is coming towards us. It maybe, you know, before the latest data we maybe said it was 2026, 2027. I believe we're not that far away anymore from crossover point. And actually, when the cost becomes comparable, that will be a huge boost for acceptability of the vehicles to customers. But they won't be as cheap as vehicles were in the past to buy. Neither ICE engines, nor hybrids, nor EVs. That's the bad news. The good news is they'll be cheaper to run.
Yeah.
Because the cost of servicing is lower, but also the cost of fuel is lower. It depends on tax as well, of course, it does. But the efficiency savings are there to be harvested by all the consumers at the moment. So since 80% or more of customers in new cars currently buy on PCP contracts,
yeah,
the cost of the new car once the residual values start to stabilize for EVs, the cost of having a PCP of an electric vehicle will be very comparable with the cost of an ICE engine car.
Just while we're talking batteries a little bit, what should we make of the solid state talk? Everybody presents the solid state battery as a panacea, as the bold new tomorrow. Is it? But it reminds me of what Elon Musk used to say about hydrogen. Hydrogen is the fuel of the future and always will be. And I sort of slightly wonder about what's up with solid state batteries. They work in the lab, but nowhere else, it would seem.
Steve, it'll come back to horses for courses. So for smaller, lighter applications, the solid state charging and capacitance will be fine. But if you want your 300-mile range, or if you've got to move 20 tons of freight, we're a long way. With current technology, we're a long way away. But for a last 5 or 10 kilometer delivery vehicle, it'll happen. As soon as it's commercially viable.
Yeah. Mike, just talking about the fact that plug-in hybrids are going to be able to survive 5 years longer in UK. Do we have any guidance yet from the government about what is going to be a 2030 to 35 plug-in hybrid? How it's going to be battery dependent? Pretty battery dependent, I imagine.
Yeah, it's watch this space. The government's probably going to publish a green paper on this. They say the spring, but obviously a government's definition of the spring is pretty elastic.
Yeah.
So probably before Wimbledon takes place. What they said in the original publication was that you got to do significant miles at zero tailpipe. Now, accepting what we've just been talking about of total life cycle costs and so forth, they're going to come up. They need to find a way that allows and gives confidence to the market. Now, go back to what I said earlier. We don't want that hockey stick where you just bumble along. People either not buying vehicles because the fastest way to address environmental concerns, whether that's climate change or air quality issues, is continual fleet renewal. Take the old cars off the road. So you need to give confidence to the consumer. That's one of the reasons why they've extended the timescale for plug-in hybrids. Well, it just says for hybrids. They've got to come up with a way that allows you to define what it is. It will not be mild hybrids, but it will be potentially plug-in hybrids, full hybrids, whether they look at some sort of methodology where a proportion of a journey has to be under electrified zero tailpipe propulsion. So if you think about, if you're driving for 30 miles round, and so forth, that range you can probably do on a plug-in hybrid straight. But then, what proportion over a 200-mile range would be done on a full hybrid, which doesn't offer you that longer concentrated EV, but will dip in and out of EV propulsion. So it's a bit of a difficult one to define. But I think what they want to do is they've allowed that, and indeed the industry needed that, because 2030 total cutoff was just going to be impossible for everyone, or virtually every single manufacturer. No one could support 2030. 2030 plus 5 years just about allows you to do that, given the market transition and the consumer acceptance issue, which is, fundamentally, you can put the cars on the market, and they are doing, doesn't mean people can afford to buy them or will buy them.
Should we be surprised by the fact that no other nation has, well, as far as I know, no other nation has made the same announcement? Does that make us look as though we're doing something wrong?
There's a few. Obviously, Norway's looking at 2025. Netherlands, similar. California's now saying 2035. I know California is not a nation, but
almost, yeah.
It's big enough to be.
Yeah.
So others are going there, and I go back to what I said earlier about COP26 and the importance of that to the UK government, and getting other countries to sign up to similar ambitions. You'll see Europe get much, much tougher. Biden administration, we'll see what they do.
Yeah, I see. What do you see in the future, all of you, as the way the government will compensate itself for the sort of 30 billion or whatever it makes from oil taxes? Because it's going to have to, I mean, that there has to be a, well, I'm interested in two things. They're going to have to make an announcement soon, surely, about a policy. And they're going to have to start doing something, aren't they, pretty soon?
It's a good question. I mean, if you think, undoubtedly, they're now on a slippery slope in terms of fuel duty revenues. However, that said, always remember the majority of fuel duty, I think, is still attributable to road haulage. And that's, you know, as we've said, that's a much harder nut to crack in the transition to zero.
Yes.
They do, in some stage, they're going to have to grasp the nettle, and we know, you know, these ideas about paper mileage, when you drive, where you drive, and have a, you know, it's a spending model like that is going to come at some point. But remember, this government, well, no government has grasped the nettle on fuel duty for over a decade now. We came off that escalator, haven't touched it, politically very sensitive. As soon as you touch it, front page of some tabloids, war on the motorist. They're nervous about that. So I think if you are going to do it, make a shift to some sort of road pricing, you'll do it in the first year of an elected term, because it is going to be controversial.
Oh, I see. It's somebody I was talking to recently, Richard, you might want to offer on this, was saying that this is connectivity's most important function, almost.
I think it's the most important function is safety, actually, but I certainly think it's important. I agree with Mike. I think the answer to this dilemma of revenue raising to cover the external costs of motoring, which are legitimate, by the way. It's perfectly fair to charge the motorist for external costs imposed in society. So some sort of revenue attached to that needs to be raised, let alone the need to balance the budget of the government. And I believe road pricing will be the answer. It's a logical answer. And the technology is either there now or coming soon. With the connected cars, we know where the car is all the time. And therefore, it's quite possible to levy a charge depending on where you're driving, what time of the day you're driving, which day of the week you're driving, and do a kind of road pricing menu, which is dynamic. So you can incentivize people to find more efficient ways to travel their desired journey. If they have a choice, they can not only avoid the time delay of congestion, but also save money. So, and if you're in a hurry, you can pay extra money to get there faster, exactly when you want.
Yes.
So I think something like that will happen, probably with a kind of base allowance for everybody to avoid being regressive tax. So you give everybody allowance, and then you pay over their allowance.
I
So
see.
most people can rotor for free, but many people will go further, or in peak times have to be a bit more. Something like that is possible with connected cars.
Guys, the government actually have started, because they put so when you buy a new vehicle, take a new vehicle on charge now, there's nearly 500 quid's worth of VED, which you have to cost for. So clearly you don't for EVs at the moment, but it isn't hard to bring that in, particularly for the bigger, heavier vehicles. So government's already doing things at the moment to try and compensate for declining fuel duty revenues. Might make the point about the freight haulage association, and that hits everyone in the pocket. But there are clever ways to do this. Clearly, road charging is one of those, and which is absolutely spot on. Then there's variable charging you can make depending on it's one of the new ways to deal with congestion as well. So just make it damn expensive to drive at certain times of the day. We're kind of getting more used to working from home now. Obviously, if you work in a factory, you can't do that. But more and more jobs can be done from home these days. And you can have things, even new things like webinars for the IMechE from home. You know, there's breakthroughs coming through.
Richard?
May I link this back, Steve, to the conversation we had about hybrids?
Yes, please do. Yeah.
I believe that a potential answer to the hybrid dilemma is to link it to the connected car technology. So basically, you can have a system whereby you pay a levy on the vehicle when it's used using purely electricity for energy, versus when it's used in ICE mode.
Oh, I see.
So you can basically use the connected car technology to ensure that the customer is incentivized financially to charge up the battery on the hybrid electric vehicle instead of forgetting about that and only filling it with liquid fuel. It's very easy to do this, and you also link it to what's called geofencing, where you maybe charge more for burning fuel in the city, but more outside the city.
That gives. I take your point about safety. It certainly gives connectivity a really important role, doesn't it? That. Yeah. Could I just a sort of IMechE question? Given the way car and the sort of mobility demand for personnel is moving, what are the best ways to get qualified as an engineer? Is it still good to be a mechanical engineer, or do you need to be doing electronics or something different? Where's the demand for engineers these days?
Well, certainly, Steve. I'm sure Richard can answer this as well. Certainly, I'm reasonably well attached to a few academic institutions, and certainly the amount of electronics and control and software and embedded software capability is growing dramatically. So you'll still need us knuckle dragging mechanicals to do the heavy lifting. But just in our world of automobiles, the software side, the control side, the clever side is massively increasing as a percentage of value in the vehicle, and there is a shortage of capable software engineers out there. And as you look at JLR, they're employing people all over the world to work in small pockets because they have to. So there'll be this. As far away as South Korea and Manchester are JLR employing pockets of control and software engineers. Massively important and growing in importance.
Yeah.
I would like to see, I'd like to add to that by saying, I'm not sure there's one discipline I would advocate. We need many engineers. Data miners, software, as was said, electronics, electrical, mechanical. But I'd love to see, this is what I'd love to see, the promotion of mechatronics engineers, because we really need to integrate better mechanical discipline and electronic disciplines to maximize the synergy between the two approaches. Most modern and mechanical systems are actually hybrids, where we overcome the laws of physics a bit by using electronic control to modify what would otherwise be linear characteristics. We introduce non-linear behavior using clever electronics to modify the characteristics. That's where mechatronics engineers can really be hugely helpful. So I'm all for a new emergent discipline.
Are the academics onto this?
They have been for a long time, but it's for some reason it's been trendy, but hasn't really gained traction.
Oh, I see. Interesting. Oh, well. You've got university connections, haven't you?
Yes, I have a few. And, the great thing about working with academics is diversity of opinion is encouraged.
Very good. Usually. There's a very good question here from a gentleman called Colin Warburton, who says, How will you handle the inevitable backlash when the public realize that the coming changes will not give them the freedom and flexibilities they were used to?
I'm not sure I agree with the proposition behind the question.
Okay.
I think one of the wonderful things about this generation we're talking about of new vehicles is they preserve exactly the compelling advantages that have made the motor car so popular, overwhelmingly popular over the last 100 years. You know, I just want to throw a piece of data into the conversation. In this country, 90% of all passenger kilometers take place in cars, not in other forms of transport on the land. And that just goes to show how well suited the solution is to most people's needs and lifestyles. So the challenge we have is not to reinvent the mode of transport, it's to preserve its huge compelling advantages and reinvent the technology that we use to enable that mode that's sustainable and is zero carbon.
Yeah, what a fantastic way. We have, believe it or not, run out of time. Thank you, gentlemen, for that fantastically lucid explanation of a load of curly questions. I learned a lot myself. And thank you, IMechE, for presenting us with the opportunity. John.
Thank you very much, Steve. And thank you particularly to our panelists. That has been a really, really interesting discussion. A number of things that I hadn't previously considered, not least the 2.5 million engines in the UK that we make that mean that we've got to replace those jobs. Some of those applications will be in heavy vehicles, some of them will be in export, and I'm sure Brexit will have a role there. But the impact across passenger car, how that flows across to heavy vehicle, and how we run urban transport, refuse vehicles, bus fleets, things like that. There are a number of solutions. It's been really interesting to hear a range of different views. So thank you to all. Thank you to our audience as well for their questions. Please keep an eye on the IMechE calendar. We have a number of different events coming up across various sectors. But I will leave you to your afternoon. Thank you very much, everybody, for participating.
Bye-bye. Thank you.
Bye-bye.